Hi everyone. All right, so for this lesson, we're really going to focus on learning a new way to kind of solve these different triangles. So your warm-up is kind of just doing a recap of just basic trig that you guys learned previously. So I'm going to kind of skip over that, but I would definitely recommend you guys take a few minutes and actually go through this problem if you need to, just kind of a recap. But we're just going to kind of dive right in. So whenever we're solving triangles, what that means is that you need to find all the missing sides and all the missing angles. So some important info that you really need to know is that your uppercase letters are going to represent any of your angles, and your lowercase letters are going to represent all of your sides. So I know it's a very small detail, but it is going to be very important. And then a really important detail that is often overlooked, especially when it comes to applications later on, you need to know that your biggest side is going to subtend and be across from your biggest angle. And then same idea also applies for your smallest side. It's going to be across from your smallest angle. So in order to solve your trig ratios, you guys know that we've solved using what we call SOHCAHTOA, which SOHCAHTOA is just in reference to your trig ratios up here. So sine, which is opposite over hypotenuse, cosine, which is your adjacent over hypotenuse, and then tangent, which is your opposite over adjacent. So I know that's the mnemonic that you guys have used for that, but when you use SOHCAHTOA, that is specific to right triangles. The types of triangles that we're now going to solve are going to be what we call oblique triangles. Now, these oblique triangles essentially are just a fancy way of saying they're not right triangles. So the first little method that we're going to look at is what we call the law of sines. So down here, I'm actually going to kind of prove the law of sines. I know I kind of give you like what it actually is over here, but I want to work our way up to it. So I'm actually going to kind of move this over a smidge, and we're going to work over here in this figure. So I need to label it first. So across, I know this is actually a lowercase, this really should be an uppercase. And then same idea over here, this really should be an uppercase B. And then same idea over here, this really should be an uppercase letter C. So as we mentioned, angle A is going to be across from side A. So I know this over here is going to be side A. So now I'm going to get rid of that. And then across from angle B is going to be side B. So over here, this is going to be side B. Okay, and then once again, get rid of this. And then angle C over here is going to be across, and it's going to be from side C. So this will be side C. So now I'm actually going to reference and do triangle ACD. And then I'm also going to reference triangle BCD. So I'm going to use both of these triangles for proving law of sines. So what I'm going to do is I'm going to start with doing sine of angle A. So that's going to be the opposite over the hypotenuse. So opposite of A is going to be, opposite of A is going to be my H value over my hypotenuse of that triangle, which will be my B value. So that's going to be B over H, H over B. And then same idea, now I'm going to do sine, but now I'm going to use angle B over here. So I'm going to do sine of B, and then that's going to equal the opposite over the hypotenuse. So opposite of angle B is going to be the height over the hypotenuse, which is going to be A. So H over A. And then what I'm going to do next is I'm going to solve both of these equations for my H value. So on this side, I'm going to multiply by B. So I'm going to have H equal sine of A. Well, oops, let me move that over. Let me put my B value on the front. And over here, I'm going to multiply by the letter A. So then I will have H is equal to A sine B. And then notice how we have two H values. Well, they both represent the height, so these values are going to be equal. So I'm going to actually set both of these values equal to each other. So B sine of A is going to equal A sine of B. And then what I'm going to do next is I'm going to divide both of these values by both of the side lengths, A and B. And when I divide, notice how on the left side your B's are going to cross out, and then on the right side your A's are going to cross out. So this is going to leave us with sine of A over A equals sine of B over B. And then by extension, that's going to lead into this formula here for your law of sines. So this is really saying that sine of that angle and then the size of that side, or the length, is going to be proportional to every single side. All right, and then if I want to find the area of this triangle, well, we know the area of a triangle is going to be half the base times the height. So for the first part, I'm going to leave it as 1/2. And then in this triangle, the base in this case is actually going to be C. So I'm going to have C times the height, which is going to be my H value over here, which we mentioned over here that my H value is either B sine of A or A sine of B. So it doesn't really matter which one you do. So there's going to be different variations. So I'll do like B sine of A. But because there's multiple variations, this is only one way to write it. So you can actually rewrite the law of sines using a couple different other variations. So we can also do it as 1/2 AB sine C. And then we can also do AC sine B. So all three of these equations will work when you're finding the area of a triangle in regards to law of sines. All right, now to kind of build on it, so now we're actually going to solve some of these problems. So just know that when we're doing law of sines is specifically only going to work with a few different triangles. So we have angle, angle, side, and we have angle, side, angle that they're going to work for. Now later on in a future lesson, we're going to cover what we call ambiguous cases, and that's going to be for side, side, angle. Now, of course, be careful how you write it, but hey, take your chances. But know that when we get to ambiguous cases, that's going to be an extension of law of sines, which that's going to be, of course, like I said, in another lesson. All right, so starting off, we're going to use the law of sines to actually solve these triangles and find the corresponding area. So I give you three values in this case. So in this case, I give you angle A, angle B, and then side A. So once again, kind of a throwback, uppercase letters are going to represent your angles, lowercase letters are going to represent your sides. And then you need to find all the missing components. So we need side B, we need angle C, side C, and then the area of the full triangle. So when I draw my triangle, just keep in mind, no triangles are going to be drawn to scale. So anytime I draw a triangle, I'm going to distort it a little bit on purpose. Well, that's not really distorted, but I'll do this. Whatever. All right, and then you can label it however you want. So I'm going to do A down here, B up there, and C way over yonder. But you can really put them wherever you want. So I'm going to label the given information. So we have 53 degrees over here at angle A. Angle B is going to be 62 degrees. And then we have side A, which is going to be across, is over here. All right, so when you're doing law of sines, what I recommend is you're really going to look for a pair. You're going to look for a set where you have both uppercase and lowercase of that same letter. So in this case, I have a set of A's that we can use. So I'm going to set this up, and I'm actually going to go ahead and do law of sines to find side B. All right, so for my setup here, I'm going to have sine 53. That's going to be over the side, which is 8. And I'm going to set that equal to sine of 62. And then that's going to be over side B. And then you're going to treat it just like you would a proportion, and you're going to solve for side B. So you can cross multiply. So I'm going to do this side and then this side, multiply these values. So I'm going to have B sine 53 is going to be equal to 8 sine 62. And then to solve for that B value, I'm going to divide both sides by sine 53. So my value here, we're going to have 8 sine 62 over sine 53. All right, I'm going to move y'all up here. All right, and then when you get to this part, then this is what you're going to type in your calculator. So I'm going to take a second. When you are typing in your calculator, notice how your values, we're measuring angles in degrees, which means you need to be in degree mode on your calculator. So that is extremely important. If you calculate all these values in terms of radians, you're going to pretty much be doomed from the start. So I have my calculator right next to me. I know y'all can't see it, but that's okay. So when I type in, I do 8 sine 62 over sine 53. So that's going to give me a b value of 8.84456. So that means I'm going to write 8446. So whenever you're doing work or you need like your values for other answers, you're always going to want to use 4 decimals. But then for the final answer, you're going to use 2. So I just found B. So instead of writing the full 4 decimals, I'm just going to write 8.44. 8.84. All right, now I'm ready to move over to C. So over here, I can find that missing angle. So what I'm going to do to find angle C is you can do just 180 degrees in that triangle, and then you're going to subtract the other 2 angles. So minus 62, and then minus 53. So 180 minus 62 minus 53, that should give you about 65 degrees, I believe. Yes. So then you'll write this over here off to the side. So now that I have this 65 degrees right here, you can label it if you want to, you don't have to. But now that lets me find side C, now that I have that angle. So now over here, I'm going to move over to sine C. I'm still going to use my pair from A to help me with finding side C. So I'm going to have sine 53 over 8. And then I'm going to set that equal to sine 65. And that's going to be over C. So once again, you can cross multiply and divide. So this is going to be C sine 53 equals 8 sine 65. So when you divide both sides, that's going to be 8 sine 65, all divided by sine 53. So when you type that in, that's going to give you, whoops, typing numbers is hard. So your 4 decimal places is going to give you 9.0786. But for the actual C value for the final answer down here, I'm just going to do 9.08. All right, now I'm ready to find the area. Let's move you over a smidge, and I'm going to do the area way over here. All right, so my default for the area is doing the 1/2 AB sine C, which in this case it's going to work. So 1/2, whoops, AB sine C. So this is going to be 1/2 times my A value, which is 8, times my B value. Now, I will say over here, when you're pulling your B value, I would definitely recommend using as many decimal places as possible. So if you use 4 decimals, that's fine. Of course, it would be much more efficient if you actually did the full expansion. So if you use that whole number, but of course, 4 decimals should honestly be just enough. So I'm going to do 8.8446. And then times sine of angle C, which is 65 degrees. Okay, so, whoops. So for your area, when I type it in, it gives me 32.0637. So for your area, I'm going to have 32.06. So there is your first problem. So of course, when it comes to rounding, definitely check the directions and make sure you're staying aligned with whatever's expected. So depending on what level you're in, if on level, AP, honors, whatever, there might be different expectations for different problems, so just keep an eye on your rounding. All right, so now I'm going to jump down to number 4. So once again, I'm just going to draw any sort of triangle. It's not going to be drawn to scale by any means. That's not a triangle, apparently. All right, so I'm going to put A up here this time, because why not? So A is going to be 40 degrees, and then B, uppercase C is 75 degrees, and then they give you lowercase b is 4. Reading is hard. So in this case, I don't have a pair right off the bat, but what I can do is 180 degrees minus these two values to get angle B, and then I will have a pair right here, which I can do law of sines. So I need to find an angle B first. So the measure of angle B, writing is hard, y'all. It's going to be 180 degrees minus 75 degrees minus your 40 degrees, which is what, 45, I believe. Let's see if I can do math. I'm always going to check myself. Ooh, nope, 65. This is why I check myself, because mental math is hard, y'all. Even though I'm a math teacher. It's also been a long day. So we know that measure of angle B is 65. Okay, and then now that I know that this is 65, now I can do my law of sines. So over here, I have my combo. So you can do your combo now to solve for your A value and your B value. So let's go ahead and solve for the A value first. So sine 65, that's going to be over 4. That's going to equal sine of 40 over my A value. So I'm going to skip a few steps. So this is going to be 4 sine 40 over sine 65. Okay, so 4 sine 40 over sine 65 is going to give me 2.83695. So when you round, so I'm just going to want 2.84 for the A value. All right, now I'm ready to move on to B. So I'm still going to use my pairing over here. So, ooh, I labeled that as B. That should be a C. My bad, y'all. All right, so now let's do sine 65 over 4. All right, and that's going to be sine 75 over C. So once again, cross multiply. I'm going to skip a few steps. So we're going to have 4 sine 75 over sine 65. So 4 sine 75 over sine 65. Why do I keep writing the wrong letter? It's fine. So that's going to give me a C value. That's going to be 4.2631. 2631. So C, we're looking at 4.26. And then I just need to find the area. So I'm going to do AB sine C. So 1/2 times my A value, which I'm going to use the 5 decimal value over here. So that's going to be times 2.83695 times my B value, which is 4. And you move, and you go over there. Times 4, and then sine of C, which is 75. So when I type in for the area, so 1/2 times 2.83695 times 4 times sine 75. So this is going to give me an area of 5.4806, which final would be 5.48. So that's pretty much the rundown, the gist of it, but there's going to be a lot more to come later on. I didn't do any applications on here. We're going to save those for later on, but just for general law of sines, this is pretty much all you need to know.